Okay, we're going to go ahead and get started today. So welcome everyone to Docker Enterprise 3.1 release launch. It's great to see so many people in the webinar today. Internally, we are super excited about this as it marks the first joint software release since the acquisition of Docker Enterprise back in November. I will be your host today. My name is David Kramer, and I'm a Principal Solutions Engineer with Mirantis, spending most of my time in the field with our many customers. I hope to see many of you on the call here soon. As I will be sharing our high-level roadmap with you later in this webinar, we have to take a pause here for a brief disclaimer. I'll spare you the legalese, however, often things may move around or change priorities. This is the adventure we face in software development, so we kindly ask that you don't hold it against us. And on to our agenda. I'll quickly refresh last year's announcement and summarize Docker Enterprise as a platform prior to this release. I'll introduce the key features of Docker Enterprise 3.1 and then discuss further as we walk through some demos together. We'll look moving forward into our roadmap, briefly discuss some new support options, and then wrap up with Q&A. As mentioned earlier, Mirantis acquired Docker Enterprise in November of 2019. Essentially, all enterprise assets, personnel, and customers were transitioned during this time. We experienced a significant uplift from an engineering perspective, and this release is the direct result. Docker as an organization has since refocused and is now concentrating on specific use cases around developer productivity. So the slide kind of shows you what assets Mirantis now owns and what community assets Docker still owns. Additionally, in March of this year, Mirantis acquired the team from Katana and Lens from a multi-cluster, multi-purpose, Kubernetes-centric IDE standpoint. So in many ways, you can look at Lens as the Swiss Army knife for kube-specific IDE experiences across development, operations, monitoring, and more. It is available today, free of charge, and you can head over to the website to learn more and to download. Some of you are familiar with Docker Enterprise 3.0. This is where the team at Docker was before the acquisition. Forrester recognized Docker Enterprise as the leading container management platform back in Q4 of 2018. It was built around Kubernetes 1.14 and provided freedom of choice across the platform components and associated infrastructure. We've always positioned ourselves from a build, share, run analogy. Build any app using an integrated tooling associated with the Docker engine, share your container images seamlessly and securely within your organization using a secure software supply chain, and run your apps anywhere on DKS, or the Docker Kubernetes service in a hybrid, on-prem, or multi-cloud use case. Now I'd like to introduce you to Docker Enterprise 3.1. 3.1 offers conformant certified Kubernetes 1.17. We are offering Istio Ingress Gateway with an easy to configure experience right within UCP. We've also GA'd native Windows container support running on Kubernetes. And lastly, we're featuring GPU orchestration and support right out of the box. Additionally, Launchpad CLI is available and currently in beta. For those of you who are familiar with Docker Cluster in 3.0, Launchpad is our next generation tooling for day one setup, configuration, and future upgrading. I'll circle back to this later in the presentation and invite you to participate and take it out for a test drive. Now let's take another look at Istio Ingress Gateway. We've focused on Ingress for 3.1 and will follow up with full Istio mesh support in a subsequent release. Fundamentally, we want to reduce the complexity of do-it-yourself Kubernetes Ingress by offering a convenient and easy to configure experience right in UCP. Now let's jump into our first demo. So due to the demand on meeting platforms over the last couple of months, I've pre-recorded my demos to reduce variables. Please hang tight if your connection flickers and during the transition here, and I'll be back with you momentarily. For this first demo, I'm going to focus on the setup and configuration of Istio Ingress Gateway in Docker Enterprise 3.1. I'll walk you through this in two parts. First, from an administrative perspective, we'll install the necessary Istio components to my cluster and configure it appropriately. Secondly, I'll switch to a developer persona and deploy an application leveraging my new Istio Gateway setup. As you can see, I'm in the dashboard for UCP. For those new to Docker Enterprise, UCP is our platform control plane. At first glance, I'm immediately presented with information regarding the general state of my cluster. For this webinar, I'm using a lab setup deployed in AWS. As such, I have a single non-HA deployment of my control plane and a set of worker nodes. We can also view general monitoring information from Prometheus directly from this dashboard. Now that we understand UCP a little bit, let's move on to our Istio setup. To do this, I'm going to navigate to my admin settings, click on Ingress, and as you can see, we've implemented a simple toggle switch to deploy the necessary Istio control plane to our cluster. From an Istio gateway perspective, I can configure how many replicas I want to deploy, and I can also pin the gateway to a specific node using affinity rules. So I'll do that and then click Save. Okay, so it's that easy to get Istio set up from a control plane standpoint within my cluster. So now let's navigate to a command line and verify my installation. All right, so the first thing, as I mentioned earlier, right, I have an infrastructure node and I want to pin the gateway from an Istio deployment standpoint to this infrastructure node. I'm doing that because that is where my cloud load balancer is listening. And that's how we kind of tie, my Ingress solution together. Second thing I want to verify is that my Istio pods deployed appropriately. Okay, so now we can see that the necessary Istio pods have deployed to Docker Enterprise and they're running within the Istio system namespace. So we validated our installation. So now let's move on to step 2. My next step is to configure the actual gateway object within Kubernetes. To do that, I'll navigate down my Kubernetes object tree and select Ingress. Here we can configure gateway objects, Istio virtual services, and even view third-party Ingress solutions that are deployed to Docker Enterprise. All right, so back to gateways. To simplify the creation of required Istio objects, UCP provides a wizard-like experience to get you started. So I simply need to just click the Create button. Here I can name my gateway. I'll call it Demo Gateway. I'll select the protocol I want to use, supply a port number, a name, and then provide my required host information. All right, now I just need to generate the YAML and assign this to a namespace within Kubernetes that I want to deploy this object. I'm going to select the Istio system and click on Create. Okay, So it was that easy to create our first Istio Ingress gateway. I've now completed the administrative setup of Istio Gateway within UCP. So let's move on and deploy an application leveraging my new gateway. Let me walk you through my developer setup in context of a secure software supply chain. I want to make a change to my Pacman application. Specifically, I want to embed the Mirantis logo within the style sheet that this application uses. I have my application source code in Git. Git is integrated with Jenkins and automates my CI/CD process, including pushing my image builds into DTR and deployment to UCP. Now let's switch over to VS Code in my local Git repository so I can walk you through my specific scenario. Starting with my Jenkins file, you can see that I'm using environment-specific variables for the purposes of reusability. Items like my DTR image repo, my Kubernetes namespace, and my Docker user will all be resolved during the Docker build. Moving on to my deployment configuration, we can see an example of these variables in use, as well as the fact that I'm pulling my container image from DTR. Let's move on to my service. I've used the default service type of cluster IP for my Pacman service. Lastly, let's check out my actual virtual service object. Here you can see that I've specified the demo gateway that we set up earlier. All right, so now I'm ready to make my change. As I said earlier, I'm going to embed the Mirantis logo within my CSS. So it's already staged here. I'll just comment this out. Okay, I can now do a save. And via VS Code, I'll give it my commit message. So I added the logo. I'll do the stage and commit, and then push my changes. Okay, back to Jenkins. We can see that GitHub has triggered my Jenkins pipeline. I've loaded up the Jenkins file and resolved the variables I talked through. We've checked out the changes from Git. We're doing the Docker build. We'll automate some unit tests, push this image into DTR, where we'll scan it, sign it, and deploy it to our development environment. Because this is a demo, I'm going to proceed forward, conduct my integration tests, promote my image, sign it again for production, and then lastly, deploy my image. This is all very, very important for the whole idea of a secure supply chain. And so as a next step here, now let's move back into DTR and let's view what we've accomplished. I'm going to look at the most recent tags. I can see that this image was pushed to Jenkins 26 seconds ago. If I view the details, I can see the different layers in my image, as well as the components that are used. And here's the important part, right? I've been able to create an image with no vulnerabilities, so I can sign this image and have trust that I can use this moving forward. But let's take an example of what would happen if we found some vulnerabilities. So I have another container image. I'm going to look at a tag in this, view the details again, and you can see right off the bat here that DTR has identified 2 high, 1 medium CVEs. And so I can see what layers are of concern here. And if I click into components again, I can actually see the actual components and the associated CVEs. I can now click on this CVE, understand in detail from a developer standpoint how I can remediate my image and proceed forward from there. So now that we have the concept of this secure supply chain, we've also automated the deployment to UCP. So we're back in UCP. First, we'll see that we've created the virtual service object. And so I can click on that. And I can view it from a YAML standpoint within UCP. I can also go back down to the Kubernetes object tree, click on controllers. I'm going to set the namespace to my actual deployment. Go back to controllers. You can see that here is my Pacman deployment. Let's actually make a quick edit. We're just going to increase the replicas. So we'll set that to 2. Click Save. You'll see that UCP immediately recognized the change and is scaling up my pods. The service that I've exposed via cluster IP. And so now we can kind of complete this by going back to my virtual service, looking at the route. It's the same route that I have here already in my browser, so I can refresh, and my change is instantly updated. Also notice now, because I made an increase in my replicas, and watch the actual host here as I refresh. So we can see that change reflected. We know that load balancing and high availability from an application perspective has been achieved. And we can also see how easy this was to simply set up within Docker Enterprise 3.1. Now let's take a closer look at Windows support for Kubernetes. Over the years, we've had a great partnership with Microsoft. And in a lot of ways, we're ahead of the times in supporting Windows containerized workloads way back on Windows Server 2016. The caveat, of course, was that we deployed those workloads to Swarm. For this release, I'm happy to announce that that same ease of deployment experience natively is now on Kubernetes. We've implemented the default support of GMSA for higher security options and production-ready networking built in Calico CNI for Windows. So let's proceed now to our second demo. In this demo, I'm going to illustrate how Docker Enterprise 3.1 quickly and easily facilitates the deployment of native Windows container workloads that have been properly refactored and or configured to run in Kubernetes 1.17. We're going to be using a Windows 2019 server instance for my Kubernetes worker node. I will showcase the deployment scenario and the user experience associated with Docker Enterprise 3.1, assuming that we've already done the appropriate application refactoring. So let's get started. First, let's look at my application repo. Notice for this example, I've chosen a legacy ASP.NET application that was previously deployed in a VM-based client-server traditional architecture. I decided to leverage this older bakery commerce site and refactor it into a more modern container-based retro tech store. I've also chosen to architect this in 2 different ways. First, as a single container deployment called the one tier, which has the web front end and the database integrated into a single container image. In a 2-tier implementation, which has the web front end and the database deployed as 2 separate images. Clearly, the latter is more appropriate from an enterprise configuration. However, for demo simplicity, we'll leverage the 1-tier deployment model. The first step in preparing my Docker Enterprise 3.1 cluster for Windows workloads is to join a Windows Server 2019 node. For this demo, I have provisioned the infrastructure in AWS and completed the required setup, which includes enabling the Windows feature for containers on the OS, executing a setup script, which we provide to install the Docker engine and containerd binaries and services to the local machine. Then lastly, downloading and loading up the required Windows container images to the Docker engine on your node. Once our node is properly configured, let's see how easy it is to join that node to my cluster. And so here I'm in the Nodes Resources. Within the Shared Resources navigation of UCP, we can see the nodes listed that represent my cluster. I can easily add a Windows node via the user interface. As you can see, I can click on New Nodes. I can specify a node type, and the worker node will be defaulted from a role standpoint. Here I get a secure Docker Swarm join token, which I can copy. And now I can RDP over to my Windows node, open up Windows PowerShell, and paste in the swarm join command. We can see that this node has been joined as a swarm worker. So let's go back to UCP. Okay, now that I have a healthy Windows worker node, I can move on and deploy my application. Let's quickly review my setup so that you can track along. As you can see, I have an Azure DevOps pipeline set up to build and deploy my image to DTR every time there is a change in my source GitHub repo. Now let's move over to DTR. Here I can see all the image tags that have been pushed from Azure DevOps. If I select one of these, I'll also notice that DTR has scanned the Windows container and provided relevant vulnerabilities. We reviewed this in the last demo. Now let's examine my Docker file and Kubernetes deployment configuration. Here's my Docker file where you can see the Microsoft-based image that I'm referencing. You can also see that I'm removing the default IIS site and creating a new one for my retro store. Now let's check out my deployment configuration. I'd like to call out my Docker image that I'm using from DTR. We can also see my Kubernetes service is being deployed as a cluster IP. And lastly, notice my Istio service configuration where I'm mapping to the Istio gateway that we created in the previous demo. Okay, so now it's time to actually deploy my application. Do that, I'm going to open up terminal. I'm in my local git clone, and you can see my one tier directory. So I'm going to do a kube ctl and deploy the retrostore YAML. I'm going to do that in the launch namespace. All right, so now we have our objects deployed, and we can head back to UCP and verify the results. So first, I'm going to go back to Ingress, check out my virtual service. You can see that a virtual service was indeed deployed. Notice my deployment configuration. Again, I can pull that up in UCP. And then the pods that were deployed. At this point, I can verify my route. And we can see just how easy it is to deploy a native Windows container to Docker Enterprise 3.1. So for our customers who want to easily configure and deploy data science or AI ML workloads, this next one's for you. Docker Enterprise 3.1 now features reference device plugin architecture right out of the box. So let's check this out. All right, for this last demo, I'd like to highlight the ease of orchestrating Kubernetes GPU workloads with Docker Enterprise 3.1. For this release, we simplified the setup of GPU-centric workloads by pre-configuring the Kubernetes-specific NVIDIA device plugin and associated reference architecture. Specifically, the NVIDIA device plugin is deployed with platform setup as a daemon set. Associated kernel requirements must be enforced on all GPU nodes. NVIDIA device driver must also be installed on the Linux host with dependencies. In context of COVID-19 and current world events, I'm going to donate a GPU compute node from my cluster to the Folding at Home project. If you're not familiar with the Folding at Home project, it can be found at foldingathome.org. So let's start with my demo setup again. Here you can see my source repository. I would like to give credit to Rich Stokes for the original work in putting this repo together. Okay, back to UCP. First, UCP provides a secure and convenient way to authenticate and communicate with both the Docker engine and the Kubernetes CLI in the form of a client bundle. Here, I can generate a client bundle and download a group of certificates directly from UCP, which allows me to authorize a remote Docker engine and Kubernetes context to a specific user in UCP. I'll be using the user Pacman for purposes of this demo. Okay, similar to our Windows demo, the first step is to attach a GPU node to our Docker Enterprise 3.1 cluster. So I'm going to navigate to Shared Resources and Nodes. I'm going to click Add Node again. We're going to have a Linux worker, and I'm going to copy my Docker Swarm join token. So now let's head over to a command prompt where I can SSH to my GPU node and attach it to my cluster. Perfect. So I've attached the node as a Swarm worker. Back to UCP, we'll verify the results. Here we can see the Linux GPU node initializing. All right, so I have a healthy GPU node attached to my cluster. Now I can deploy the Folding at Home application onto my GPU node. But first, let's review the deployment. Okay, again, you can see that I'm pulling my image from DTR, and down in the resources, you can see that I'm requesting the NVIDIA GPUs. So now it's time to apply this deployment configuration to my cluster. Perfect. So we've applied our deployment configuration to the Docker Enterprise cluster. Let's head back to UCP and verify the results. Under the Kubernetes object tree, we'll first check out our deployment configuration. We can see here that we have a green status light indicating a successful deployment. Let's head back to the command line where I can verify the allocation of GPU resources. Here we can see that the NVIDIA GPU resources have been allocated as specified in my deployment configuration. Okay, I hope you all enjoyed the highlights for Docker Enterprise 3.1, but let's not stop there. As I mentioned earlier, Mirantis, Docker Enterprise, and Catena are now one unified engineering team. We have an aggressive roadmap taking the best of each individual organization and quickly moving forward to deliver more value for our customers. In the near future, you'll see us focus on lifecycle management from a platform day two perspective, multi-cluster management, both from a provisioning and configuration management perspective. And finally, you'll see us focus on federated application management for migrating, cloning, and deploying Kubernetes-ready applications. Here we see the future platform state as we work to integrate OpenStack in a containerized deployment model running on Docker Enterprise. Why are we doing this, you ask? Well, after working with containers over the last 6-7 years, I think it's fair to say that not all enterprise workloads are great candidates for containers. Examples may include COTS applications where we don't have the source code, or traditional apps that you don't iterate on. Thus, speed and agility are not the primary drivers for these workloads. As such, we want to give you choice to decide what workloads to modernize and what workloads you may want to leave running in virtual machines for a spell, all in one integrated platform. I wanted to highlight a couple of the important support changes as we move forward. Our current customers will recognize the two options on the left. I'm happy to announce that we're adding a third support option and making our traditional business support option even more robust. Moving forward, we'll have the following three models: lab care for non-production use cases, prod care for 24/7 production level support, which now includes all cases, not just P1s. And finally, ops care, a fully managed day two remote operations with enhanced SLAs. Here, we're operating as your trusted partner to ensure platform reliability and lifecycle management, so you can just focus on utilization and app dev adoption. As promised, I wanted to loop back to Launchpad. And here we can invite you to start a free trial of Docker Enterprise today. Thank you all for joining. Again, we're super excited about this release and hope to get your feedback and participation in our free trial offer. I'm now going to hand it over to my panelists to address the questions we've received in this webinar.
Hello, everyone. I'm John Janeshig from Mirantis, and I'm here with David Kramer, Aaron Reut, and Stephen Follis. And we're going to take a look at some of the questions that have come in while David has been speaking. There's a sort of a long list. The question at the top is sort of critical. How do I upgrade from 3.0 to 3.1?
Sure, John, I can take that. This is Aaron. For the upgrade from 3.0 to 3.1 is basically very similar to a patch update if you've used the Docker Enterprise platform before. Once you have the system installed, it's kind of a matter of updating the engine on all of your machines and then running through the interactive UCP installer, which is a containerized installer that you just run from the command line. And it walks you through updating your entire system. It even gives you the ability to do kind of a blue-green update. So if you wanted to even add additional nodes and only update specific nodes, worker nodes at a time, it provides that ability, as well as then upgrading the DTR component of the platform to the latest and greatest version. So even though it is a major version upgrade, the update process is very similar to patch releases.
The Kubernetes included in Docker Enterprise 3.1 is now upgraded to 1.17, correct? An attendee wants to know how this case differs, if at all, from upstream cases.
Sure. Our Kubernetes distribution, which is rolled into our Docker Enterprise platform, is a fully conformant upstream Kubernetes offering. As far as it goes, we don't really deviate or heavily customize that. All we really do is kind of wrap that into our Docker Enterprise platform and bootstrap it. So, we also apply a lot of configuration to default Kubernetes cluster to really make it more secure and more enterprise-esque.
Regarding the inclusion of Istio now as part of the sort of out-of-box experience here, do we support Istio Ingress on public cloud infrastructure as well?
Yeah, so the Istio Ingress gateway, as it is in this offering, will be on all of our supported infrastructure, and so any of the certified infrastructure that's listed on our on our documentation will be fully supported.
Will the full Istio service mesh eventually be supported?
Yeah, in this release, we've just started with the Ingress portion of Istio.
The Ingress portion.
That being the biggest ask from our customers. But in a sequential release coming up later this year, hopefully we'll have full service mesh support.
Several people have asked, jumping back to David, what editor were you using for your demos? We had answered directly in the chat, but maybe you'd like to dwell a little more on that, since we may have confused some people by showing them Lens in back of VS Code and other things that you were using.
Yeah, so I was using VS Code within the demos and had some of the Kubernetes and Docker Engine plugins associated with that. However, from a product standpoint, right, we're now kind of contributing to Lens from a developer IDE standpoint. So the next one, we'll make sure to use Lens in these demos.
About halfway through, a question that's personally very interesting to me came through. I'm not sure who to address this to, but the attendee wanted to know, can we talk more about how to implement canary or blue-green type deployments in this environment, and in particular, how to bring Istio into play to manage access to those deployments?
Sure, yeah. So I mean, all of the canary, blue-green, and everything deployment strategies that are available in Istio are also available in our product, as we are really just kind of taking the upstream conformant Istio Ingress gateway and making it available. So via your YAML, you can specify various deployment approaches and strategies, such as percentage of nodes that you want to be healthy. You can even do kind of A/B testing, where you send some of your traffic to one version of your application and some to the other. We have some examples in our documentation, and we're continuing to build out examples and additional GitHub repos and whatnot to really highlight this functionality. All of our demos we did here are available in public GitHub repos, and we'll work on trying to clean that up and make those available so that people can go and try out some of the demos that they saw here today.
Do you happen to know whether Istio will in the future have monitoring tools used from the open source version, like Prometheus, Grafana, Kala, Jaeger?
So yeah, currently in our implementation, we don't package those tools, but they could be installed and used on our platform. We're working on a product within Mirantis that will kind of bring a best-in-breed approach to monitoring that will offer as either an additional side project or as part of our ops care and other componentry that will expose the Prometheus, Grafana, Elastic Stack that will have all this available. We do run the Istio telemetry within our platform, so it is all available and can be sent off to an existing Prometheus stack within your environment, or as I mentioned, we'll be providing that functionality at a future date.
Are there available docs on migration paths from Swarm to Kubernetes within the platform? This is for people who have Swarm services running today and are interested in moving towards Kubernetes in the future.
So our services team is working on several campaigns around Swarm to Kubernetes migrations. as well as tooling to be able to do that. Right now we're not 100% sure how much that will be publicly available or how much that will be kind of behind our subscription for our Docker Enterprise platform. But it's definitely something that a lot of our customers are coming up against right now, and we're working on trying to create both webinars and white papers around that, as well as coming in and offering services to help our customers move from SOAR to Kubernetes.
Several people are interested in the GitHub repo used in the demo. I assume we're talking about the GitHub repo used in the GPU demo, the folding at home stuff. David, where did that was Rich Stokes' work, wasn't it?
It was. Originally, I did reference Rich Stokes' good work there. We've put the actual changes, which was essentially, moving and pulling the container image. I put it into DTR just from a scanning and secure supply chain perspective. And so that's posted on the Mirantis field repo. And so we will follow up and post links to both of those repositories, as well as the other examples that we used for the demos.
Jumping back out, to the sort of medium length view, can Docker EE, manage multiple K8s clusters?
So our current, yeah, you want to take that, David?
I just say Docker Enterprise manage multiple K8s clusters. I'm reading from the collective spreadsheet, and I get my own acronyms wrong.
Yeah, sorry, I'll jump in here. So in accordance to our product roadmap, we are now actually building out a multi-cluster UCP tooling. And so with 3.1, right, it is single cluster focused. As we move to the next release, it will be multi-cluster focused. And we're actually going through quite a bit of customer conversations just to kind of understand the various use cases out there. So if anyone is interested that we haven't already talked to and you want to give some feedback, we would welcome that.
It strikes me that maybe some further clarification is called for. There's no problem managing multiple clusters now with Docker Enterprise. You and I have certainly done it on numerous infrastructures simultaneously. Docker Enterprise and the various deployers that Mirantis puts in place bring information back from new cluster deployments to a deployer machine, to your laptop. They make it very easy to download individual authentication bundles and other stuff from clusters under management, so you can very quickly organize yourself to log into nodes, to access kube control on 50 different clusters if you want to. The question is, can you do it within the web UI? And the answer to that, of course, is soon.
Yeah.
But there's a lot going in the platform that assumes that probably many more than one cluster is going to be operated on.
Yeah, and just to further clarify, so, we previewed Lens. That does have context to multiple Kubernetes clusters. As John just talked through, right, can very much use Docker Enterprise to manage multiple clusters. Essentially, my control plane from a UCP standpoint in today's release will be singular in focus. As we move forward, we're going to add configuration management as well as multi-cluster provisioning in a unified control plane experience.
Can we talk a little more about the CLI tool to install and upgrade Docker Enterprise?
Yeah, I'm going to hand back to Aaron for that one.
Yeah, sure. So, I mean, if you go to the docs.mirantis.com website and you kind of go through the installing UCP or DTR, it walks you through using basically a Docker command. So Docker, it's a Docker/UCP container that you pull down and you pass it, it's tagged with the version of UCP that you're installing, and you pass it parameters. You can run it in interactive mode. It supports a lot of different ways of running a UCP, install, update, and a various set of commands as well. There's also one available for DTR that does exactly the same thing. It provides the ability to join DTR replicas, update them, back them up, and do all of those various things. And so, while you can kind of deem it a CLI, it's actually more of a container, and that you just run using Docker commands.
I'm trying to interpret this question. Someone asks, I saw you join the node into Docker Swarm. How do they become available in the Kubernetes cluster? I guess that's about what the default orchestration is, join new nodes as, role selection system is for.
Yeah, so the whole Docker platform is kind of built on top of a Swarm bootstrapper. And so when you add a node, this is kind of one of the powerful features, is when you add a node, you can choose whether it is a Swarm or a Kubernetes node. And actually the UCP will spin up a reconciler and a bootstrapper on that node and install the required Kubernetes or Swarm components on that node. So you join a node to the Swarm cluster, and then you can designate Kubernetes, and it will install the kubelet, kube API proxies, and all of the different componentry that's required automatically. And so you don't have to go through and manually configure that host in any way, shape, or form. You install the Docker engine, you do a Docker Swarm join to UCP, and everything can be configured and changed via UCP from that point
on. Are there different licensing models for non-production environments? I guess this goes back to the how do you install clusters question, sort of, because it relates to Launchpad and recent changes in the licensing model.
Yeah, so the licensing model for the paid product is kind of a core-based licensing, and then based on the level of support that you want. So we do have, as kind of David had showed, we have an offering of prod care versus lab care or versus ops care, and so those all priced at a different point. So usually a non-production environment would be licensed under more of like a lab care model, which is slightly cheaper than a prod care model, but once again, it doesn't provide the 24/7 support. So typically we work with our customers to really understand what that environment's being used for, and then we can offer them the best options as far as licensing that. Because while some companies will have clusters that they don't deem production, they are what maybe their developers are using to build and test their applications. When that cluster goes down, you're basically out of service. And so while some people may not deem that a production cluster, you may want production support on that cluster. And so this is something you would typically work with, your account team or whoever, or within anybody in Mirantis to kind of figure out what the best options are there. And like you saw on the slide, we have quite a few different offerings, from anything from basic support all the way through fully managed service support.
Then we have a series of quite technical questions. I guess the simplest: do we or will we have a how-to to set up the demo environments for around Pac-Man? That demo seems to have interested several of our attendees. It might be a reasonable subject for a tutorial. No, David?
Yeah, a tutorial or a blog. It's actually fairly straightforward, so we can take that as an action item and maybe post an upcoming blog here, and we'll reference all the repos as well.
It's a good test case because it incorporates, both a semi-realistic application and, Windows platform features and Ingress components. Reading down the list. Someone wants to know, does Launchpad work in Windows Home Edition?
I could take that one. So Launchpad is distributed as a cross-platform binary. And so while I have not personally tried Launchpad with the Windows 10 platform, I have tried on Windows 10 Professional. I do not anticipate any specific platform SKU related features inside of Windows Home that may be an issue. I do know that historically the Docker runtime did have issues based on some of the Hyper-V components that are not in Windows 10 Home. However, because we distribute Launchpad as a binary and not as a container, that should not be a problem. And I also believe that Docker Inc. with Docker Desktop community has very recently increased support for the Docker engine on Windows 10 Home. So even if we did, it should work either way. So have not tried it, but do not suspect that there would be any known issues there on Windows 10.
And I believe that's pretty much all the time we have. Any closing words, David, Aaron, Stephen?
Again, I think we want to thank everyone for your interest and participation in today's webinar. We will follow up with the recording of today's webinar, as well as links to repos and some of the other information that was asked.
Thanks for joining us, everyone. Have a great day and stay safe.